Hey guys, hoping all is well with everyone. So in this video we are going to be looking at our question of the day that asks us to find the slope of the line that passes through the points -1, -3, and 2, -5. Now this is going to be kind of an application of linear equations. So when students are approaching this question, one of the reasons that they can get pinged or points off if it's a free response or choosing the incorrect choice on a multiple choice exam is because of their inconsistencies of their substitution step when they are plugging in the x and y coordinates into the slope equation. So this video is designed in a way that allows you to see the step-by-step breakdown that allows you to ensure that your substitution step is 100% accurate. Now keep in mind there's a couple ways that you can approach this. But again, the most important thing is that you have to be consistent. So I'll explain that as we go. But the first step is going to be to simply write out the slope equation. Okay, so keep in mind that when we're looking at our slope equation, there's two kind of ways that we can look at it. We can look at it from a quantitative perspective as well as a qualitative. So since this is a situation where we're given 2 points, we're going to go ahead and approach it quantitatively. But we're going to use that variable m for slope, and that's going to be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, just to go a little bit more further into it, I will also represent the qualitative equation, and that's going to be that m is equal to rise over run. Now, what does that mean? So slope is a ratio of the changes in the y-coordinates of 2 points over the change in x over 2 points. So another way that you can think of it that you may also see is that it's equal to delta y over delta x. Okay. So now that we have our slope equation written and kind of interpreted, step 2 is going to be a really pivotal one, and it's going to be to identify your first and second point as well as the x and y coordinates of those points. So this is where the housekeeping really helps out here. So what we want to do here is we're given 2 points, and I'm going to use colors to kind of make it a little bit more differentiated, is that when we look at the points, remember every coordinate or ordered pair is designed in a way that is x, y. X being the first coordinate and y being the second. So it's important that we identify those in this step here. So here I'm going to choose that this first point out of the two is just my first x coordinate and my first y coordinate. So I'm going to label those as x1, y1. And then for the second one, I'm going to label this as my second x coordinate and my second y coordinate. Now, in this case, it's just a verbal statement, so you can read it left to right and say, okay, my first point is going to be -1, -3, and my second point will be 2, -5. But the reason I want to call your attention to that is that you're not always going to be just given a verbal statement. Sometimes you'll be given a coordinate plane and a linear equation embedded in it, and you'll be given 2 points, and then you'd have to decipher what your first and second points are. The moral of the story is it does not matter what your first and second points are, but that you are consistent as you take your substitution step in this next step and make sure that you are putting them in the correct order, because subtraction is present as an operation in this equation. That is going to drastically affect your outputs here. If it was plus, it wouldn't matter, but in this case it will. So your third step, now that we've identified our x and y coordinates of each point, our step 3 is going to be substitute all identified coordinate values into the slope equation. Now I'm going to take this one little extra step further, and I'm going to go ahead and rewrite my slope equation here. So this is going to be m equals y2 minus y1 over x2 minus x1. Okay, so now this is where our substitution step comes in. And another thing that I like to do for, again, housekeeping purposes is if I see negative numbers, I'm going to put them in parentheses. So we have y2 in the first number of our numerator expression. So that's going to be -5. And then we still have the operation of subtraction here, so we're going to go ahead and put that. And then y1 is the y-coordinate of the first ordered pair. So that will be, put that in red, and that's going to be -3. Okay, and I'll put that all over. x2 is going to be the second x-coordinate, and our second point we've identified as 2, -5, so the x-coordinate there will be 2 minus, and then the first point x-coordinate will be -1. So now we can go ahead and simplify this. So remember, when we're dealing with, adding integers or, adding those numbers, we can use that keep, change, flip method. So it's kind of the KCF, so to speak. So KCF, and that's going to be keep, change, flip. So that's kind of a way that you can approach the simplification of adding integers or subtracting integers. So what we'll do is K means keep, which means you keep the first value. That's going to give us -5. Change means that you change the operation or do the inverse operation of the original one. So the opposite operation of subtraction is plus. And then you flip. Flipping is the opposite of the other number, or the second number. So it's going to be the opposite of -3, which is +3. And again, I'll keep it in parentheses just for housekeeping purposes, even though it's no longer negative, just to differentiate the two pluses here. One being the mathematical operation, one being the sign on the 3. Okay. And then we'll do the same thing for the bottom. So we have keep, change, flip. We'll keep the first number. We'll change the operation from subtraction to plus. And then we'll flip or do the opposite value of the second number, which will be the opposite of -1, being +1. Okay. And then we can just do some simplification here. So -5 plus +3 is -2, and then 2 plus +1 is 3. So that means that your slope is going to be -2/3. So remember, when it comes to the step-by-step approach of this, the most important one is going to be step number 2, just identifying what you're going to consider your first point and your second point, and then labeling your x and y coordinates as such. Okay, but I hope this helps you guys out. If you have any questions or requests with the approach to any slope-related questions, especially ones that may involve more complex negatives or anything like that, or even ones from a graphical question as opposed to a verbal statement, I'd be more than happy to show you guys a step-by-step there. But I hope this helps you guys out. Have a wonderful and happy holiday season, and thank you so much for watching. Bye.